So let's deal with relations and functions. So supposing A comma B is an element of relation R, is A comma A an element of R? So A comma B is an element of R. Is A comma A an element of R? I would give you an example of, say, Shrutika and Divyavarshini. Okay, Shrutika comma Divyavarshini is an element of a relation, by the relation being Malti aunty students. Will Shrutika comma Shrutika be an element of R? Obviously the relationship is Malti aunty students. It's still valid. That's the meaning of this. And so A comma B is an element of R. Is A comma A an element of R? If it is so, you can call it as reflexive. Okay, where it will not be, let me say one simple example, take for example uncle and me. Okay, uncle and me. Uncle is the husband of Malti aunty. Will uncle be a husband of himself? I'm sorry to say this, it will not be. So it will not reflexive. So Malti aunty is a wife of uncle. Will Malti aunty comma Malti aunty be, what is it, the wife relationship? It will not be. So then the simple example where it cannot be reflexive. I'm just quoting a layman's example for you to understand what reflexive really means. So next is A comma B is an element of R. Is B comma A an element of R? So in the case of Shrutika and Divyavarshini, even if I switch it, there will still be an element of relation when it comes to students of Malti aunty. Whereas the same example of uncle and me, where uncle is a husband of Malti aunty, can Malti aunty become a husband of uncle? So simple layman's example that I could tell you is this, where it will not be symmetric, but if it is so, then it's called symmetric. And A comma B is an element of R. Is B comma A an element of R? Yes, it's true, then it's called symmetric. Let's go for the next one, which is called transitive relationship, where we are going to include another person. Say like A comma B is an element of R. That is Shrutika comma Divyavarshini is an element of the relation. B comma C is an element of R. This B has to occur again with another C. Obviously, if it's about students of Malti aunty, A comma C will also be an element of R. You get to understand. A comma B is an element of R. B comma C is these two are given. In this case, these two have already been given, and the question is A comma C extremes an element of R? In comes to students, yes, they are. So in that case, you'll call it as transitive. But it may not. To give you a normal layman's example, I can say, supposing you have a gym friend, or you have an outside friend who is a neighbor for you. So that girl, let's call her as some X, is a friend of you. What's your name? Maya. Oh, there's another Maya from BVM. Okay, so then this it's a person X and Maya are friends because you happen to be neighbor. But you and Shrutika, are schoolmates. So it's not necessary that the neighbor of you will be a friend of Shrutika. Even though you are friends and you are friends, it need not necessarily be friends. In that case, it's not transitive. But however, if you're all belonging to one school, they're all friends. So A comma B is an element of R. B comma C is an element of R. Is A comma C an element of R? Then it becomes transitive. So here you need to include two elements, AB and a BC, to check for transitivity. So these are the general things that you're supposed to know. If all the three are okay, adhering, then you call it as equivalence relation. And equivalence relation is one in which it will be reflexive, symmetric and transitive. Are you clear? So next, what can I say? I'll give you a simple example of two parallel lines. Okay, an L1 and an L2. So the relationship here is a keyword parallel. So L1 comma L2 is an element of R. Is L1 comma L1 an element of R? Is L1 parallel to itself? Yes. Since L1 will be parallel to L1 itself, it will be reflexive. Correct? Next, L1 comma L2 is an element of R. Is L2 comma L1 an element of R? The relationship is parallel. If L1 is parallel to L2, L2 will also be parallel to L1. So therefore it is symmetric, because L2 is parallel to L1, and so it's symmetric. Transitive, of course you have to include one more, as I said. L1 comma L2 is an element of R. L2 comma L3 is you can speak L2 comma L3 is an element of R. Is L1 comma L3 an element of R is the question, correct? And you know, if L1 is parallel to L2, L2 is parallel to L3, obviously L1 and L3 will also be parallel. L1 will be parallel to L3, therefore it is transitive. A simple example of an equivalence relation is to 3 parallel lines or 2 parallel lines, whatever it is. So next, let's talk about another simple example is perpendicular lines. Suppose there are lines L1 and L2, and the whole relationship here is defined by perpendicular. So then let's write it. That L1 comma L2 is an element of the relation is perpendicular. Is L1 comma L1 an element of R? No, because L1 will not be perpendicular to L2. Reflexive. It will not be, so it's not reflexive, because you're talking about reflexive. Suppose you compare an L1 with an L1 only, I'm sorry. So then therefore it is not reflexive. So L1 comma L2 is an element of R because L1 is perpendicular to L2. Is L2 comma L1 an element of R? L2 will also perpendicular to L1. From the diagram you can see, and right. So therefore it is symmetric. Yes. Will it be transitive? For transitive you need one more line, which is L1 comma L2 is an element of R and L2 comma L3 is an element of R, which means L1 is perpendicular to L2. L2 is perpendicular to L3, which means where is L3? Okay, by the diagram, you know, L1 and L3 are only parallel. They are not perpendicular, they are not transitive. It's very simple. Look at the diagram, you will know. So then the question is L1 comma L3 an element of R? L1 is not perpendicular to L3, therefore it is not transitive. So this is one good example where it's reflexive and it's not reflexive, it's not transitive, it's only symmetric. So general idea as to how to write a reflexive and symmetric for a simple parallel lines and a perpendicular lines. Of course you understood with a husband and wife and stuff, which is very, very simple. So slowly we're building up and making it more complicated. Let's see. So next thing that I want to tell you is let me declare a set. Let me declare a set 1, 2, 3. So in which I'm going to write some relationship. So I can write many relationships which are equivalence, which means it will be reflexive, symmetric and transitive. So this is a very important learning which every student must listen very well. The relationship 1, I'm trying to write an equivalence relation. If I write it has to be reflexive, I have to have a 1, 1. If each in this elements has to be reflexive, means it should be 1, 1, 2, 2 and 3, 3, then that's what will make it reflexive. Look at this, if it's just 1, 1, you would think that it's reflexive, right? Because 1, 1, so you will think it's reflexive. No, the condition for reflexivity, very, very important, that each and every element on the set has got to be reflexive for a relationship to be reflexive. I raise my tone and say this. You cannot go to the test and forget about this, okay? When I write a relationship, the whole point of reflexivity becomes very complex because each and every element on the set, declared set, has got to be reflexive. So merely writing 1, 1 will not make it reflexive. You have to necessarily write it with 2, 2 and a 3, 3. Close it. So you know definitely this is reflexive. Yes, because each and every element on the set again is reflexive, so that makes it reflexive. Yes. Now you know this is definitely reflexive. Now the same relationship I'm going to check for symmetric. Switch it, will it change? So it is symmetric, correct? Because 1, 1, when you switch it, it's still 1, 1. It's not a problem, so it's okay. So then therefore it's symmetric. To check transitivity, you know the middle element has to be same. I have told you transitivity means Shrutika, Divyavarshini, and Divyavarshini, Maya. You have to compare like this so that the extremes can be relatable. So this has to occur twice. Then only you can even check for transitivity. Look at this, is the middle letter anywhere coming? 1, 1 is there. Is anything starting with a 1? 2, 2 is there. Anything starting with a 2? 3, 3 is there. Anything starting with a 3? So you are not able to check for transitivity. Not that it's not transitive. You are not able to check for transitivity, then it is transitive. So the key points here is when I talk about reflexivity, each and every element on the set, declared set, has got to be reflexive for it to be reflexive. And the complication for transitive is when you are helpless, when you are not able to check for transitivity, you can merely write it as transitive. Are you clear? With regard to symmetric, this is symmetric. So this is reflexive, symmetric and transitive. So you can call this as one of the equivalence relation. This is one equivalence relation. Correct? So let me write another equivalence relation R2 from the same set. You know it has to be reflexive, it has to compulsorily have 1, 1, 2, 2 and a 3, 3. Now I'm going to build on it. I can't leave it like that. I have to include something. So I'm include a 1, 2. To make it symmetric, I'm writing a 2, 1 and close it. So if you see there's a 1, 1. So that makes it transitive. Correct? 1, 2 is there, 2, 1 is there, 1, 1 is also there. So that makes it, what is it? It is reflexive, symmetric and transitive. Not symmetric, I've switched this also. Correct? Okay. The next equivalence relation is R3. Wherein again for reflexive, you know each and every element on the set A. So then 1, 1, 2, 2, 3, 3. Then leave 1, 2, write something else. Write 1, 3 and a 3, 1. That makes it definitely reflexive, symmetric and transitive. So I'm written another relationship or R3. Let's go to relationship 4. So you have to write 1, 1, 2, 2, 3, 3 compulsorily because we are trying to write an equivalence relation which is reflexive. What is left over? We can write 2, 3. Write 2, 3 and include a 3, 2 which makes it symmetric and transitive. Here comes a relationship 5 baby where I'm trying to write 1, 1, 2, 2, 3, 3. I'm going to take 2 at a time. I can include a 1, 2, make it 2, 1. Also I write 1, 3 and a 3, 1. I am trying to close it, thinking that it will be equivalence. But look at this, I have a 2, 1 and a 1, 3. Do I have a 2, 3? So which means it is not transitive. So then in order to make it equivalence, I have to write a 2, 3. And in order to make this symmetric, I have to write a 3, 2 and close. That's made it exhaustive. I've used up everything. So the relationship 5, beyond this I cannot write anything more. Are you clear? So then how many equivalence relations is possible on a set 1, 2, 3? You have 5 equivalence relations. And a general formula, very important question which will come for every exam, to how many equivalence relationship is possible is 2 to the power n minus n, where n stands for the number of elements in the given set. How many elements are there? 2 to the power 3 minus 3 is 8 minus 3 is 5 and you got a 5. Beautiful. And this is exactly the same question that will be asked in every exam. It'll ask you MCQ. Number of equivalence relation with set n elements, or n elements, is it 2 to the power n, or is it n factorial, or is it 2 to the power n minus n, or 2 to the power n minus 1, something like that. They will give you 4 multiple choice. But we know what is the question that will come for BMM. This is the question that will come for boards also. You know the question, you know the answer. Okay, so then you're clear with whatever I taught. So then this is the general formula. Wind up with this. Next, let's go to textbook sums. This is the introduction. No, before that, I want to give you more introduction. Little more is, let's talk about on a real number. On all the real numbers, the relationship is A is lesser than or equal to B. This is a relationship. They normally give it in set builder form, no? R, where R is equal to double bracket A is less than or equal to B, where A and B belong to an element of R, something like that in set builder form. You know set builder form. So the question is A is lesser than or equal to B. That is the relationship. You're going to check for reflexive, symmetric and transitive. First give numbers and justify it, so that you are clear with your understanding. You know 2 is lesser than or equal to 4. Will 2 be lesser than or equal to 2? This equal to is there, so you can say yes. So you can say a 2, 4 is an element of R. Is 2, 2 an element of R? Such that A, B is an element of R. Is A, A an element of R? Yes, it is true. True. Therefore it is reflexive. Let's look at symmetric. You know 2 is lesser than or equal to 4. Is 4 lesser than or equal to 2? So you know it's not symmetric. But however, you can't put S and cross. I'm just doing it. It's my way. My handwriting is bad as such. I don't want to write symmetric like this. So I'm just putting S cross. But it's not symmetric. You should write. So you know that 2, 4 is an element of R because 2 is less than or equal to 4. Correct? But 4, 2 is not an element of R because you know 4 is greater than. So then therefore it's not symmetric. So let's talk about transitivity. 2 is lesser than or equal to 4. 4 is lesser than or equal to 6. So the question is 2 lesser than or equal to 6? It's true. Therefore it is transitive. Correct? 2, 4 is an element of R. 4, 6 is an element of R. 2 comma 6 is an element of R. Perfect. Therefore it makes it transitive. It's reflexive and transitive but not symmetric. But however, this is not enough. Giving only examples is not sufficient. We should be able to write it alphabetically. That comes only in the second stage. First you have to prove it numerically so that your brain has accepted the fact that it's reflexive, it's not symmetric, but it is transitive. Now you prove it as alphabetically. How to prove it? A is lesser than or equal to B is the relationship. A can be lesser than or equal to A. So true. That makes it definitely reflexive. Alphabetically mudichachu. A is lesser than or equal to B, but B will never be lesser than or equal to A. So it's false, right? It's not. So then therefore it is not symmetric. A is lesser than or equal to B, B is lesser than or equal to C, A will definitely be lesser than or equal to C, therefore it's true and therefore it's transitive. So this is the alphabetical representation of this sum. Very, very easy. Okay, this sum is very easy, but it's not necessary every sum it will be easy. So I taught you the first example being A is less than or equal to B on a set real numbers. Again, next question is on a set real number. I'm going to talk about A is lesser than or equal to B square. I have to be very careful in this because a real number means it can be rational, irrational, fractions. So if I sit in the exam hall, I can't think of examples because this question is about you have to disprove. Because if you put whole numbers, it will become true. Just like A is less than or equal, you put integers, it might become true. So then what I want to do is not integers, whole numbers or natural numbers will become true. But the question is you have to disprove. It's neither symmetric, neither reflexive, neither symmetric, not transitive. You have to disprove. So you can't use 2 is less than or equal to 4 square and do that. You have to think really deep. And for me to think in an exam hall is very, very difficult. The moment I get the question paper, I get stressed out. So this question will be asked exactly like this, and I want children to remember the examples that I am saying. So a 1 by 3 comma 1 by 3 will not be an element of R. Why? Because 1 by 3 is not lesser than or equal to 1 by 3 square. The moment 1 by 9 is greater number. So to be definitely, you understand? So then therefore 1 by 3 comma is not, therefore it's not reflexive. Proved. So what's the example? 1 by 3 comma 1 by 3. Next example again mug. 2 comma 6 is an element of R. Is 6 comma 2 an element of R? Let's see. 2 is lesser than or equal to 6 square because relationship is like that. And 6 is not lesser than or equal to 2 square. That it's not symmetric. So 2 comma 6 is an example. Are you clear? The next example, if you had come for my offline class, so whoever missed my offline class that day, I will say it like this, like I'll show you when you come for the class, I'll say it like this, right on your face, a 3, a 2, a 1.5. I like as if I'm going to say get set, go, ready, but a 3, a 2, a 1.5 is an example. So you're going to compare a 3 and a 2 and a 2 and a 1.5 to prove it's transitive. We have marked up the examples. 3 is lesser than or equal to 2 square. 2 is lesser than or equal to 1.5 the whole square. But 3 will not be lesser than or equal to 1.5 the whole square because it's 2.25. See, I've just memorized it. So then therefore 3 comma 2 is an element of R. 2 comma 1.5 is an element of R. But 3 comma 1.5 is not an element of R. Therefore it's not transitive. So the example is 1 by 3, 1 by 3, 2 comma 6 and a 3, a 2 and a 1.5 is the third example. Okay, so you clear with this. So that's about it. These are the examples you need to give to prove this. Next is let's talk about supposing. Okay, it's not transitive. So it's neither reflexive nor symmetric nor transitive. Done. So next question could be A is lesser than or equal to is B cube on a set real number. Again I want you to mug up this because on a set real number it could be fraction. So remember the same example 1 by 3 and 1 by 3. So 1 by 3 is it lesser than or equal to 1 by 3 cube? No. Therefore it is not reflexive. There I wrote an example 2 comma 6. The previous sum where A is less than or equal to B square. Is slightly A is less than or equal to B cube, no? The 6 sum you just ulta and write it as 9. The same example but a 2 comma 9. So 2 comma 9 is the example I am quoting here where I know 2 it's for symmetric, right? 2 comma 9 is an element of R because 2 is lesser than or equal to 9 cube. Is 9 comma 2 an element of R? Is 9 lesser than or equal to 2 cube? 8. It's not. So therefore it is not symmetric. Unless you have this hands-on, we will panic in the exam hall, because as such the problem is to complete the paper on time. Everybody comes back and says, I couldn't complete this last sum. By the time I was writing the fourth sum, they took away the paper. Every time board exam, somebody or the other have a time management issue. Not everybody has got the speed. So we have to be sure of textbook sums hands-on, so that only extra sums you need to use your brain. We have to use your brain for everything. But so are you clear? The next example for transitivity. What was the example I gave you last? 3, a 2, a 1.5. Now I'm going to change the tune a little bit. 3, 1.5, 1.2. It's easy to remember. So this example is 3, 1.5 and a 1.5, 1.2. Okay, you know 3 is lesser than or equal to 1.5 the whole cube. And you know 1.5 is lesser than or equal to 1.2 the whole cube. But 3 will not be lesser than or equal to 1.2 the whole cube. We calculate and see. We are not even calculating. This is what the answer is. So then therefore it will not be transitive either. So these examples you got to memorize when it comes to, this is very simple. A is less than is equal to b is very simple. So then a is less than or equal to b square gets complicated. B cube gets even more complicated. You know both all the answers now very clearly. Correct? So next now we'll start the textbook sums. Okay, now I'm going to do exercise 1.1. So those who have taken leave, who were not present, please make sure you're learning everything from this video. Okay, so Vishwesh, it's for you that I'm making this video specifically. I know the previous video would not be sufficient. Please learn everything from here and be ready for next class. So on a relation R, on a set A, what is set A is given to be 1, 2, 3, ... 13, 14. What is the relationship? R is given by x comma y, where 3x minus y is equal to 10. I'm recording, no, once again. Yeah. So 3x minus y is equal to 10 or 0. I'm sorry, 3x minus y is equal to 0. What is the meaning of that? It means y is equal to 3x. Correct? This has been given in set builder form. Let's write in roster form. You know, when x is 1, you have to choose both x and y from the set A. So when you write x is 1, you get y as 3. X is 2, y is 6. Say x is 3, y is 9. X is 4, y is 12. X is 5, y is 15. Why are you shaking your head? I'm not supposed to write that. I just wrote it to see if you, yeah, because 15 cannot come. So I'm trying to make a mistake and show you so that you won't make that mistake in the exam hall. Okay, so you must remember this. So 4, 12, stop it. Now look at this relationship. Is it reflexive? Do you have 1, 1, 2, 2, 3, 3, 4? No. Each and to make it reflexive, you know that each and every element on the set A has got to be reflexive. So how do you explain that? Maya, you have to write 1, 1, 2, 2, ... 14, 14 is not an element of the relation. Correct? Yes. A comma A is not an element of R, therefore it is not reflexive. So every element starting from all this is not an element of ours. Everything has got to be there. Now is it symmetric? 1, 3 is there. Do you have a 3, 1? So then therefore you can say it's 1, 3 is an element of R. A 3, 1 is not an element of R. That shows that it is not symmetric. That is when writing you know, A comma B is an element of R. B comma A is not an element of R. Correct? So it's not symmetric. So transitive. Can we check for transitivity? Yes, 1, 3 is there, 3, 9 is there. But 1, 9 is not there. So write the same example. 1, 3 is an element of R. 3, say with me, 3, 9 is an element of R. Is 1, 3 an element of R? 1, 9 an element of R? Extremes. No, it's not an element of R. So that shows that it is not transitive either. You are able to check for transitivity and it is not transitive. So it's not. If you're not helpless, like if you're helpless, then it's transitive. But here you're really able to check for transitivity and it turned out to be not transitive. Okay, so then therefore it's this is what it is. But when you write like this, the teachers are not happy. You have to think like this numerically and approach it alphabetically. How to approach it alphabetically? What's the relation? See what I'm writing. An x comma y is an element of R because 3x minus y is equal to 0. Is x comma x an element of R? And x in the place of y you have to write x. So 3x minus x will be 2x, and you know x ranges from 1 to 14. So it will never be equal to 0. Therefore it is not reflexive. Next, x comma y is an element of R by the relationship 3x minus y is equal to 0. Will y comma x an element of R, which means what it should be, 3y minus x is equal to 0 is what you're going to check. This is to prove. Correct? But look at this, what is it here? You know that x is nothing but y by 3 or y is nothing but 3x. You know y is equal to 3x. On substituting back here, what do you get? 9x minus x is equal to 8x, and again it can never be equal to 0. So from here you are trying to substitute here and say that it can never be equal to 0, therefore it is not symmetric. So transitive, x comma y is an element of R by the relationship 3x minus y is equal to 0. Then y comma z is an element of R, 3 elements is required, is an element of R, which means 3y minus z is equal to 0. I am following the same pattern. So to prove will be what? X comma z is it an element of R, which means 3x minus z is it equal to 0 is what is to prove. You have to use the first equation and a second equation in such a way that you get an x and a z. You already have an z here, so substitute y in terms of x from the first equation here. So it will become 9x minus z is equal to 0. Is it the same as this? If LHS is not equal to RHS, that shows that it's definitely not transitive. Beautiful. So much clarity you have. So let's go to next question. This is alphabetical way of proving it, okay? So next question is the second question, where on a set natural number, which they've given to be R is equal to x comma y, where y is equal to x plus 5 and x is less than 4, and you know the natural number means x is only 1, 2 and 3, because it clearly states the rooster form, set builder form says less than 4, no equal to is there. So it's only x can be 1, 2 and 3. So we're going to, relationship is y is equal to x plus 5, and this x and y has to come from only, okay, x can be 1, 2, 3, y can be any natural number, because what we have defined here is only x. Y need not be 1, 2, 3. Yeah, so you substitute, right, set builder form, x is 1, y is 6, x is 2, y is 7, x is 3, y is 8. Stop it. Is it reflexive? You don't, for reflexive what should be there? Not only 1 comma 1, you should not 2 comma 2, 3 comma 3. Everything has got to be there for it to be reflexive. So just don't say 1 comma 1 alone, because for reflexivity the main condition is each and every element on the set. I raise my voice for you to remember, and yet you are forgetting. So then 1 comma 1, 2 comma 2, 3 comma 3 is not an element of R. That is a comma a is not an element of R, correct? So therefore it is not reflexive. And you know that 1 comma 6, do you have 6 comma 1? No. So 1 comma 6 is an element of R, 6 comma 1 is not an element of R, therefore it is not symmetric. For transitivity, are you able to check for transitivity? 1 comma 6 is there, 6 comma something is not there, 2 comma 7 is there, 7, you are helpless. It is transitive. This is what children will not notice. When you are helpless, it becomes transitive. But you can't write I am helpless, I am transitive. So you just write the statement for condition for transitivity, that's all. You just write the condition for transitivity and leave it like that, okay? So then what is the condition for transitivity? I am not even giving an example. Yeah? I am going to write a comma b is an element of R, b comma c is an element of R, a comma c is an element of R, therefore it's transitive. I'm helpless now, I'm writing one statement and leaving like that. Okay? No, don't give anything. You can say 1 comma 6 is an element of R, and there's nothing to compare, so then therefore it's transitive. And write this entire thing so that you are safe. You understand what I'm saying? So now here comes an issue. I have to prove it alphabetically. I always told you, you have to do it numerically so that your brain understands what you're writing, and then prove it alphabetically. Now I'm going to do it alphabetically. You will see the way I'm going to make mistake. It's very important for a teacher to make mistake and show you so that you won't make that mistake. And I make this mistake, you will see me making it. Can you see what I'm going to do? For reflexive, what's the relationship? Y is equal to x plus 5. Will x be equal to x plus 5? Therefore it is definitely not reflexive. Sort it. I've explained it alphabetically. You know y is equal to x plus 5. Does it mean that x is equal to y plus 5? No. You know from here x is equal to y minus 5, and so they are not equal, therefore it is not symmetric. So here and here I've proved it well. numerically and alphabetically. But look at what I'm going to do for transitivity. Okay, just see. X comma y is an element of R because y is equal to x plus y. Y comma z is an element of R because z is equal to y plus phi. To prove x comma z is an element of R, right? Which means z is equal to x plus phi is what I have to prove. I need a z and an x. I have a z here, I have to write y. What is y? Z is equal to, oh, I'm getting it, x plus phi plus phi. I'm getting z is equal to x plus 10 and they are not equal. Okay, fine. But I'm getting, therefore not transitive. But however here, do you see that if I do it alphabetically, I can get into problem? Correct?
Yes.
It is becoming like not transitive. But however it is transitive. So what you do, quickly rub it. Because your brain knows that it is definitely transitive. Because you can't check for transitivity. Because you were helpless. So similarly in answer also I am helpless. I am writing something which turned out to be wrong. I am showing this. So then therefore your teachers what they will do, they will just not do the sum numerically at all. I mean alphabetically at all. They will just leave it. You understand what they'll just keep quiet. They will not even ask you to prove this alphabetically. It's their convenience. When it comes, they'll ask you, why didn't you do? When they don't get it, they'll keep quiet. They'll be happy with the numerical. I hope nobody uploads all. Therefore, in the sum, you don't even bother. You just write these statements and leave it like that. You write this also as a comma. Of course, you can prove this alone. X is not equal to x plus phi, and then this is y is equal to x plus phi, but x is equal to y minus phi. It's not the same. So therefore, it's not. That's all. That's enough. In this one, don't even open your mouth. Just keep quiet. Okay. Just silence is the better answer when you don't know, and that's what it is. Okay. So let's go to the next question. The next question is the third question. The third question is on a real number. Oh, they have given set A, so that solves a problem. It's not real number. On relation R. It's just a relation R, it's not real numbers. So then it's 1, 2, 3, 4, 5, 6 is the set that's been given. They're asking you to write the relationship. The set builder form is y is divisible by x. Y is divisible by x. That is the second term can be divided by the first term. So each number can be divided by itself. So then therefore in the Rooster form you can write 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Each and every element on the set A is there, so it's reflexive. When you write itself, it's reflexive. Other than that, divisible means 1 can divide every number. So 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Then it's 2, 4, 2, 6. Then it's a 3, 6 and close it. Okay, so then this is what it is, and you can't switch it, because if y can be divided by x, x cannot be, 1 can divide 2, but 2 cannot divide 1. So it's definitely not symmetric. As soon as you see, it's reflexive. As soon as you see, it is not symmetric. Transitivity, 1, 4 is there, 4, 4 is there, and 1, 4 is there. What else? 1, 2 is there, 2, 6 is there, 1, 6 is there. So it is transitive. So as soon as you see, it's reflexive. It is not symmetric, but it is transitive. Yes, good examples to quote it. How do you represent? From 1, 1 till 6, 6, every element is an element of R, so it is reflexive. So 1, 2 is an element of R, but 2, 1 is not an element of R, therefore it's not symmetric. For transitivity, as I told you can quote one example. 1, 2 is an element of R, 2, 6 is an element of R, 1, 6 is an element of R, and therefore it is transitive. It's only not, it's so simple examples, but I have to write it alphabetically. Again, I will write it in my own words. X, y is an element of R because x divides y. Correct? Sorry. X, x is an element of R because x can be divided by x. Answer will, x by x is 1. So therefore it's reflexive. So x, y is an element of R because x divides y, but y, x is not an element of R. Correct? Because if x divides y, y doesn't divide x. Not all y's can divide x, not all y's, correct? So then therefore it is not symmetric. And for transitive, you know, x comma y is an element of R because x divides y. I would write, okay, you can write it like this: y by x is equal to some lambda. You're able to divide, which means you're able to divide. This will be a natural number on an integer. That's when you can divide it, correct? So then y comma z is an element of R, which means z can be divided by y, which will give you some mu, which is also an integer. To prove is x comma z is an element of R, which means can you divide z by x is the question. Are you getting a gamma, which is an element of integer? This is to prove you have to use equation 1 and equation 2. You multiply 1 and 2. The y and y will get cancelled. You will get a z by x, which is lambda into mu. An integer into integer will be an element of integer, which can be called as gamma. Correct? Lambda. What am I writing? You cancel the y and y, you get a z by x, which will be lambda into mu, which will also be an element of integer, so you can simply call it as gamma, and so therefore it is transitive. Are you clear? Yes. So that's what is the sum is all about. Let's go to next question. The next question is the fourth question, where on an integer, set integer, the relationship R is given by x comma y, where x minus y is an integer. That's all. You know x comma y is an element of R because x minus y is equal to some integer. It's called lambda, which is an element of integer. X comma x, will it be an element of R? X comma x, I'm sorry, x comma x, x minus x will be 0, which will be an element of integer. Therefore it is reflexive. So x comma y is an element of R because x minus y is equal to lambda, which is an element of integer. Is y comma x an element of R? You know, y minus x will be minus lambda, which will again be an integer. Therefore it is symmetric. Transitive. X comma y is an element, sorry, x comma y is an element of R because x minus y is equal to lambda, which is an element of integer. Y comma z is an element of R because y minus z is equal to mu, which is an element of integer. Is x comma z an element of R, which means you have to prove that x minus z is as some integer, let's call it as gamma, which is an element of integer. This is to prove. So you just add both. Excellent. This equation 1, this is equation 2, y and y get cancelled. It's always doing a manipulation like this. So you know that x plus, you get, y and y get cancelled, x minus z is equal to lambda plus mu. An integer plus integer will always be an integer. Therefore it's gamma, which is an element of an integer, so hence proved. Correct? So that this is completely alphabetical only because there's nothing else, it's general. There's no 1, 2, 3, there's no sets that's been given. So let's go to next question. The fifth question, I will be doing only C sum because all of the sums are stupid sums. X and y work in the same place, x and x work in the same place, y and x work in the same place, x and y work in the same place, y and, how stupid it is. So x and y live in the same locality, x and x, okay. So I'll do only the C sum, where the question is R is equal to x comma y, where x is exactly 7 centimeter taller than y. Okay, you know it will not be reflexive because x will not be taller than himself, so it's not reflexive. You know it will not, will it be symmetric? It will not be because x is taller than y, doesn't mean y is taller, it will be shorter. So it's not symmetric. Will it be transitive? X is taller than y by 7, y is taller than z by 7, x will be taller than z by 14. So should I have to do this sum? I don't have to. I am sure with all this you know how to narrate this answer, correct? So can I go to next? So it's neither reflexive, nor symmetric, nor transitive, correct? So the next sum we can sue CBSE. We can. I've been saying this every year that we can sue CBSE for giving x is a wife of y. Imagine transitivity. X is a wife of y is a wife of z. Will x be a wife of z? Doesn't that sound something really wrong? So then they are reducing half mark for even centimeter, meter square and everything. Look at this, for years and years they are not correcting the textbook. Isn't this an illegal question to ask? I don't know why they can't change it. Can't you just remove this shit, this whole thing? Okay, so sorry. Let's go to next. So this whole sum skip. So let's go to second question. What is second question all about? A is less than or equal to b square. I've already taught you in the introduction. Next question. Let's go to next question. So then, therefore, third question is on a set 1, 2, 3, 4, 5, 6. The relationship R is given by A comma B. So should I switch off the AC for some time? Is it too cool? Fine. Okay. R is equal to A comma B, where B is equal to A plus 1. The second element is 1 greater than the first element, correct? So all of them has to belong to this. So what will you write? You will write if A is 1, B is 2, A is 2, 2 comma 3, 3 comma 4, 4 comma 5, 5 comma 6, 6 comma 7. Again you are shaking your head. I am not supposed to write that. I always write wrongs to identify if you are able to say no. Okay, so that you are 100% listening to the class. So then that's it. This shows that it's not reflexive, because each and every element on the set which is starting from 1 1 till 6 6 is not an element of R, therefore it's not reflexive. What about symmetric? It will not be. Obviously B has to be greater than A by 1. It will not be symmetric. So write 1 comma 2 is an element of R, 2 comma 1 is not an element of R, therefore it's not symmetric. Transitive, can you check for transitivity here? Yes, you can. 1 comma 2 is an element of R, 2 comma 3 is an element of R, but 1 comma 3 will not be there because the difference is just 1. Is not an element of R, makes it not transitive. However, you have to prove it alphabetically. Again, this is numerical done. Let's take this relationship. A comma B is an element of R considering B is equal to A plus 1. Will A comma A be an element of R? Is A is equal to A plus 1? No. Therefore, it's not reflexive. A comma B is an element of R because B is equal to A plus 1. Will B comma A be an element of R? Will A be equal to B plus 1? You know from here A is equal to B minus 1. Therefore, it is not symmetric. So, you are taking the first one and solving the second one. Transitivity, you are taking the first one solving the third. Very, very easy. So, A comma B is an element of R. B comma C is also an element of R by way of B is equal to A plus 1. Here C is equal to B plus 1. To prove A comma C is an element of R, which means C is equal to A plus 1 is what is to prove. Take the first equation and second equation. You want C and A. You already have a C. You have to write B in terms of A, which is A plus 1. So C is equal to A plus 2. They both are not equal. That disproves that and therefore it's not transitive. Always try to justify your answer numerically, because you know I got into soup in one of the sums. I proved it to be not transitive, but it was transitive. That is the learning. You should always be careful. You should do it as an example and then justify it numerically, alphabetically, because sometimes alphabetically works. Correct? Yes. So then let's go to next question. Next question is A is less than or equal to B. I've already done that. On real number, A is less than or equal to B. Remember, we did 2 is less than or equal to 4. It's not symmetric, but it will be reflexive and transitive. Remember? Next question, A is less than or equal to B cube. We did that. Okay, so let's go to next question. So my introduction will cover, give you so much clarity that you have to learn the exercise like how I am saying. Fully you know what is the process of learning. Everything you are so clear. Let's go to next question. The question number 6 is, can you see on a set 1, 2, 3? They have just given the relationship which consists of only 1 comma 2 and 2 comma 1, which shows that it is only symmetric. It is only symmetric. It's neither reflexive nor transitive. So that's the answer. Let's go to next question, 7th question. So on this is library book. I don't want to. X and Y is a library book. X and X will be library book. Y and you want me to do that? Okay, let's go to 8th question. The 8th question is on a relationship where it's A comma B, it's ordered pair, where mod of A minus B is an even number. When they say even number, I will write it as 2 lambda. Because for me, even number is a multiple of 2. So I'll write it as 2 lambda. That's all, close it. Okay. So now, they have already given me what is A, which is 1, 2, 3, 4 and 5. And I have to write this relationship. Come on, look here. 0 is an even number. You know that? 0 is also, from now you know. 0 is an even number. Be very clear. Therefore, the relationship can have a 1 comma 1, a 2 comma 2, 3 comma 3, a 4 comma 4 and a 5 comma 5. Because when you subtract them, you will get a 0 which will be multiple of 2. 2 into 0, 0. Then what all I can write? Subtraction should lead me 1 comma 3. When I subtract, I should get an even number. So I can write a 1 comma 3, a 1 comma 5, a 2 comma 4, a 3 comma 5. And don't you think it's mod of 2 lambda? So multiple of 2 can be negative. I can always switch it. I can switch everything. So this will be 3 comma 1, and this will be 5 comma 1, a 4 comma 2, and a 5 comma 3, because I'm allowed to switch everything, because even if we switch, it will be subtraction will be negative, but yet it is mod, so it will be positive, and they're all the same, therefore it is symmetric. Let's check for transitivity. Take any example. 3 comma 5 is there, 5 comma 1 is there. Do you have a 3 comma 1?
Yeah.
We can switch it. We are allowed to switch. Didn't I switch 1 comma 3? I didn't. 3 comma 1. Correct. A 3 comma 5 and a 5 comma 1. I have a 3 comma 1, which makes it reflexive, symmetric, and transitive. How do you write? You know that 1 comma 1 till 5 comma 5 is an element of R. So A comma A is an element of R, therefore it's reflexive. Then you know you can switch it. 1 comma 3 is an element of R, and 3 comma 1 is also an element of R, and therefore B comma A is an element of R, which makes it symmetric. And example 3 comma 5 is, this is 3. My 3 is very bad, I'm sorry. 3 comma 5 is an element of R. 5 comma 1 is an element of R. 3 comma 1 is an element of R. Shows that A comma C is an element of R, therefore makes it transitive. But however, we have to write it alphabetically. Okay, so what is the relationship? Here it is. And A comma B is an element of R, provided mod of A minus B is equal to 2 lambda. Will A comma A be an element of R? A mod of A minus A is equal to 0, which is nothing but a multiple of 2. Therefore, it's reflexive. So, A comma B is an element of R. Is B comma A an element of R? Here you know mod of A minus B is equal to 2 lambda. Mod of B minus A will also be 2 lambda only. So, therefore, it makes it symmetric. Here comes the toughest part. B transitive. A comma B is an element of R, and B comma C is an element of R has been given. To prove will be A comma C isn't an element of R. The condition is mod of A minus B is equal to 2 lambda, and for this it's mod of B minus C is equal to 2 mu. To prove that mod of A minus C is equal to 2 gamma. Correct? Let's take this. There's a mod here. You can't directly use 1 and 2. You have to split this up and write negatives and positives, because what is in mod can be negatives and positives. So it will become minus A plus B is equal to 2 lambda. A minus B is equal to 2 lambda. This can be split into 2. Minus B plus C is equal to 2 mu. A B minus C is equal to 2 mu. To get this answer, you know, you should solve. This is marked as 1, 2, 3 and 4. We're going to solve 1 and 3. Because when you add B and B gets cancelled, you actually get a C minus A. You get a C minus A is equal to 2 into lambda plus mu, which can be written as gamma. Yeah, and you can always switch this and put a mod, doesn't matter, is equal to 2 gamma. Correct? So I've solved, I got this. I'm going to solve 2 and a 4. Solve 2 and a 4, B and B again gets cancelled. A minus C is equal to 2 into lambda plus mu, which can be again written as gamma. And you can always include a mod. So these steps, when it is mod, in transitive, you have a little bit of work to do. You have to split them as negatives and positives. So that's about it. Are you clear? So then that has proved to be transitive. You know it's reflexive, symmetric and transitive. This is the second part of the question. This question is always a board exam question, whatever I'm doing here. They are asking you, look at read the line. 135 is related to, is it related to 2,4? You draw this, write 135. And write 2, 4. Will it be anyway related? Because it has to be even number. You subtract, you get a 1. Minus 1. Subtract, you get a 1, zigzag. Do everything. You will never get an even number. So you actually get a null set in this relationship. The relationship between 1, 3, 5 is related to 2, 4 by means of a null set. So no elements of 135 is related to 2, 4. So 135 can be related only to 135, because when you subtract you will get even numbers or zeros and everything, correct? And similarly 2, 4 can be related only to a 2, 4. So no elements of 135 can be related to 2, 4. Why? Because you end up getting a null set. When you subtract, you're not getting even numbers. You should write it in words and be done with this question. So let's go to 9th question. 9th question is relationship R, where A comma B is defined by mod of A minus B is a multiple of 4. When I see multiple or divisible, no, I'll write is 4 lambda. Okay, and you know that what are the sets given? On a set A, where x is an element of integer, where x can be lying between 0 and 12. You know, every number can occur because zeros is possible. So you start writing rooster form with 0 0 1 1 dot 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 12 comma 12, everything, because if suddenly you subtract this and this will be zeros, and 0 is a multiple of 4. Then you have to write 0, add a 4, it will be a multiple of 4. Add an 8, it will be a multiple of 4. Add a 12, it will be a multiple of 4. Then go for 1, add a 4, become 5. When you subtract, it will be 4 and correct. Add an 8, then add a 12. You can't. Correct. I can't write a 1 comma 13. I'm trying to write and show you don't do that. Okay. So then 2, add a 4. You have to write 6. 2, add an 8. 2, add a 12. You can't do it. So 3, add a 4. 3, add an 8. So when you subtract, you get 8. So it will be divisible. So then next is 4. Add a 4. 4, add an 8. Correct. Next 5, add a 4. Then that's all. You can't add an 8, it will become 13. 6, add a 4. Add a 4, it will become 10. I'm sorry. Add a 4, it will become 10. I can't do anything more, right? 7, add a 4. Yeah. 7, add a 4. It will be 11. It's okay. Then no more. 8, add a 4. 12. Don't you think I can switch all this? Because it's mod of a minus b, so I can write let's write everything. Come on. And this is also already reflexive only from here. 4 comma 0, 8 comma 0, a 12 comma 0, a 5 comma 1, a 9 comma 1, a 6 comma 2, a 10 comma 2, okay, a 7 comma 3, 11 comma 3, 8 comma 4. I shouldn't write again. 8 comma 4, 12 comma 4, 9 comma 5. Okay. I hope I'm not repeating again. Yeah. And then 10 comma 6 and 11 comma 7 and 12 comma 8. That's all. Because from here it's repetition. So like this you keep writing. Half your time goes away in writing an ordered pair. So then they will not ask you to list the ordered pair in this question. But still I've listed. The question will be prove it alphabetically. They won't say prove it alphabetically. They won't ask you to write it in roster form. You just have to you've justified it numerically because there's a danger involved. You have to always justify it numerically because we can make mistakes. I can make mistakes. So then therefore I'm writing 0 0 till 12 12 is an element of R which makes it reflexive. And symmetric, yes, it can be switched. 1 comma 5 is an element of R. A 5 comma 1 will be an element of R that makes it symmetric. For transitive I can choose anything. We can choose a 4 comma 12 and a 12 comma 8. A 4 comma 12 is an element of R, a 12 comma 8 is an element of R, a 4 comma 8 will be an element of R that makes it transitive. But how to prove it? Alphabetically. Just go for this. A comma B is an element of R because the fact that mod of A minus B is equal to 4 lambda, will A comma A be an element of R? The mod is A minus A is equal to 0, which is equal to element of 4 lambda. True. It's a multiple of 4. Therefore it's reflexive. A comma B is an element of R because mod of A minus B is equal to 4 lambda. Will B comma A be an element of R? Mod of B minus A will also be the same 4 lambda, therefore it's symmetric. Here comes the next, last sum. For transitivity, A comma B is an element of R because mod of A minus B is equal to 4 lambda. B comma C is an element of R because mod of B minus C is equal to 4 mu. To prove that A comma C is an element of R, which means mod of A minus C is equal to 4 gamma. And this is mod, so minus A plus B is equal to 4 lambda. A minus B is equal to 4 lambda. Minus B plus C is equal to 4 mu. B minus C is equal to 4 mu. So you have equation 1, 2, 3 and 4. As usual, solve 1 and 3, solve 1 and 2 and 4, you will get the same answer just like last sum. You can continue. I'm not going to write it. Okay, so let's go to next question. The second part subdivision in this question is so easy, where the relationship A comma B, where A is equal to B. A is equal to B, sorry. Obviously A will be equal to A. If A is equal to B, B will be equal to A. A is equal to B, B is equal to C, A will be equal to C. Therefore, it's reflexive, symmetric and transitive. We don't have to do this sum, right? Can I go to next sum? The 10th question. I'm going to give you examples. They've asked for something which is symmetric, but neither reflexive nor transitive. Look at this, Maya. When they give you questions like this, you know what I'll do? I'll very smartly write 1, 2, 3. This question, you know, the question number, I will give the same question back to them. Okay, you know, on the relationship, I'll write, that's a 6th question, where you have 1, 2 and a 2, 1, which made it symmetric, but was neither reflexive nor transitive. The same thing, give it back to them. That's all. So let's go to second question. Second question is transitive, but neither reflexive nor symmetric. Again, declare a set 1, 2, 3. Everywhere I'll always declare a set 1, 2, 3. It has to be transitive. So you write 1, 2, a 2, 3 and write a 1, 3 and close the bracket. So this is definitely neither reflexive nor symmetric. It's only transitive. So let's go to third question. Here comes the important question where it's reflexive, symmetric but not transitive. So it has to be reflexive, which means on a set 1, 2, 3, I have to write each and every element, which is 1, 1, 2, 2, 3, 3. Then it should not be transitive. If I leave it like this, it will become transitive also, no? This is a equivalence relation, correct? So therefore, I have to include something. I'll include 1, 2 and a 2, 1. It becomes transitive. It is becoming transitive. Therefore, I have to include another number, which is 1, 3 and a. Therefore, to make it symmetric, I have to write a 3, 1. Now, you see, it is not transitive. Remember, I taught you this is relationship phi, in which we wrote 2, 3 and a 3, 2. The beginning, I have an introduction. When I wrote 5 equivalence relation, I tried to stop here to check if it's equivalence. When I saw 2, 1 and 1, 3, there's no 2, 3. Therefore, I had to include a 2, 3 in order to make it equivalence. But here, I don't want equivalence. I don't want it to be transitive, so I'll stop it like this. I'll just include 2 and then just include 2 and don't write the third. 2, 1 is there, 1, 3 is there, 2, 3 is not there. So therefore it is not transitive. Are you clear? The last relationship, fifth relationship, don't write the 2, 3. That's all. Are you clear? Let's go to fifth question. Fourth subdivision, sorry. So it's reflexive, transitive, but not symmetric. So write S is equal to 1, 2, 3. It has to be reflexive. So in a relationship, I have to compulsory write a 1, 1, 2, 2 and a 3, 3. But now it should not be symmetric, it has to be transitive. So I'll write a 1, 2, a 2, 3 and I'll write a 1, 3 and close the bracket. So it's not symmetric, but it's reflexive and transitive. So let's go to write relationship symmetric and transitive but not reflexive. So you just write 1, 1. Because on a set 1, 2, 3, each and every element has to be reflexive for it to be reflexive. If you write 1, 1, it is definitely not reflexive, but it is symmetric, and I am not able to check for transitivity. Therefore, I am helpless. Therefore, it is transitive. So that's simple example that I can give. Even 1, 1, 2, 2 also can be a good example. Are you clear? So let's go to next question. The 11th question. On a relationship R where they've given R is equal to P, Q, where P and Q are equidistant from the origin. So can we simply write OP is equal to OQ? So you know if OP is equal to OQ, OP will be equal to OP. So P, P will definitely be an element of R because OP is equal to OP. Then P, Q is an element of R. Will Q, P be an element of R? If OP is equal to OQ, don't you think OQ will be equal to OP? Therefore, it reflexive and symmetric. Transitive, you know P, Q is an element of R. Q, R, you have to include something else. So write a big R so that this is not a part of this R, is element of R. So because OP is equal to OQ and OQ is equal to OR, you know OP will be equal to OR. Therefore, you can write P, R is also an element of R, that makes it transitive. What can you say about these points P, Q, R? They are all equidistant from the origin. P, Q and R are equidistant from the origin, which means we can say that they all belong to they are all lying on the circumference of the circle with center as O, with origin, correct? As center as O or origin. So that's what is the next. In this, they would have asked, what can you say about this points PQR? When you read the question, you'll understand. Let's go to next question, 12th question. is about similarity. T1 comma T2, where T1 is similar to T2. I don't have to do the sum because T1 is similar to T1. T1 is similar to T2, T2 will be similar to T1, T1 similar to T2, T2 similar to T3, T1 will be similar to T3. Therefore, it's reflexive, symmetric and transitive. Adi nobody needs to teach you, you know it. But second part of the question, where they are asking you to compare three triangles, where triangle 1, triangle 2, triangle 3, where is 3, 4, 5, when I write itself I notice it's a triplet, right triangle. Then they've given 5, 12, 13 which is also a triplet. And then there's a 6, 8 and 10 which is also a triplet. But this question is about similar triangles. It's about similarity. I'll write it in red color. This is about similarity. And only triangle 1 and triangle 3 will belong to this relationship because the sides are proportional. For 5, 12 and 13 will not belong to this relationship because the sides are not proportional with other triangles. 3 by 6 will be equal to 4 by 8 should be equal to 5 by 10 is equal to 1 by 2. Yes. So then therefore, the triangle 1 and triangle 3, T1 and T3 is a part of relationship R, whereas T2 is not a part of relationship R because the similarity is the relationship. So can I go to next question? The next question is the 13th question, where the relationship is about a polygon P1 comma P2. Where P1 and P2 has equal number of sides. Appo n of P1, number of sides in P1 is equal to number of sides in P2. That's a condition, correct? If you compare P1 comma P1, obviously they'll have the same numbers. N of P1 will be equal to n of P1 only, no. So P1 comma P1 will always be an element of R, therefore it's reflexive. Similarly, number of elements in P1 is equal to number of elements in P2. Number of elements in P2 will also be equal to number of elements in P1. So P2 comma P1 is also an element of R, therefore it makes it symmetric. Number of elements in P1 is equal to number of elements in P2. Number of elements in number of sides. Sorry guys, number of sides in P2 is equal to number of sides in P3. Therefore, number of sides in P1 will be equal to number of sides in P3. Therefore, P1 comma P3 is an element of R, therefore it makes it transitive. Such a simple question. But however, there is this second part of the question where they've listed a triangle with sides 3, 4 and 5. And they're asking which one of this will be related to this. This has got 3 sides. So, every 3-sided polygon will be related to this triangle. எது சொந்தக்காரன்னு கேட்குறான். கொடுத்துருக்கிற ட்ரையாங்கிளுக்கு இந்த ரிலேஷன்ஷிப்பில் யாரெல்லாம் சொந்தக்காரங்க? ஸ்கொயர் வில் பியா? நோ. So all those which are 3-sided will be related, not necessarily right triangle, because it's about number of sides. So then all the triangles in the relationship will be related to this triangle. Are you clear? So let's go to next question. The 14th question is a sum which I've already done. It's about parallel lines. But there is a second part of the question here. So you have to write that parallel condition which I've narrated earlier, and they're asking you to write what are the lines which are related to this line. All parallel lines will have only constant to be different. The slopes will be the same. So y is equal to 2x plus k, where k is an element of any real number. It can be even root 3 and all that. Correct? You know it. So then just write like this, and that answers this question. Let's go to 15th question. 15th question, they themselves have given 1, 2, 3, 4. They've given 1, 2, 3, 4. And they listed it as, can you check if it's reflexive? You have 1, 1, 2, 2, 3, 3 and 4, 4. Therefore, it's reflexive. You have a 1, 2. You don't have a 2, 1. Therefore, it's not symmetric. Is it transitive? 1, 2 is there, 2, 2 is there, 1, 2 is there. Yeah, 1, 3 is there, 3, 2 is there, 1, 2. Is it there, 1, 2? Yes. Yeah, therefore, it is transitive. So you know that this relationship is definitely transitive also. It's also reflexive, but it's not symmetric. Correct? Correct? It's not symmetric, but it's reflexive and transitive. So that answers that question. Let's go to 16th question. The 16th question is, on a set of natural numbers, the relationship R is given by A comma B, where A is equal to B minus 2, where B is greater than 6. Second number is greater than 6 means you can write the order pair. Second number can be 7. Look at this. Second number can be 8. Second number can be 9 and so on. But first number has to be 2 less, so this will become 5. This will become 6. This will become 7. And look at the MCQ and mark one of it, which is C is the right answer. You have it here. So the exercise is over. I want everybody to be thorough with this exercise and be done.